the end of this unit, you get to use it on your test for part of your test, right? But a lot of this vocabulary you might have heard or not heard before. So we're going to use it today to answer some questions on some graphs. So for example, domain and range. Clearly from that test, you don't know what domain is. So we need to practice domain and range. So domain, what is the set of possible x values on the graph? So as I read the graph from left to right, could x be anything? Does x have to be greater than 0? Does x have to be less than 0? And domain and x go with your independent variable. Range is the y values. So for example, if you launch a catapult, is the height of your projectile ever going to be negative? No, right? Negative would be like below the x-axis. And if you launch it from the ground, how is it going to go below the ground, right? So the height of your projectile will never be negative. What about the height of your projectile? Will it ever be 1,000 feet in the air? Depends on what you launch. Your ping pong ball probably won't go higher than about 4 feet, right? So the range is how high could it go? And I'm going to show you this on the parent functions next week. What is a maximum and a minimum? Just the highest or lowest y value. So the maximum height of your ping pong ball. There are these things called local max or local min. So if I show you down here on this graph, the maximum, this is going up forever and ever and ever, right? So the maximum value is positive infinity. But this dot right here, that's called a local maximum. So at one point, the maximum is 2. See how the height of this little bump is 2? At one point, this is a maximum. See how this is another little peak on my graph? At one peak, the height is 0. So those are called local maximums. And then up here, I've got my ultimate maximum. It's going up forever. So there's a difference between a maximum and a local maximum. A turning point, you've probably heard this before. A turning point is just where the graph is changing direction. So each of these, 1, 2, 3, 4, are turning points on this graph. So where there's this little bump. Increasing or decreasing? As you read the graph from left to right, is the graph going up or is the graph going down? That just means the graph is increasing or the graph is decreasing. And then I think you know what x and y intercepts are, but I put them on here. Point where you cross the y-axis or the x-axis. All right, so let's see if we can answer these questions on our resource page. Just kind of talk about this one. What's the highest y value that I can get to on this graph? I can go to positive infinity. So that's kind of the sideways figure 8. I can go to positive infinity. Okay, what's my minimum? If you notice over here, there's an arrow pointing down. So this graph can actually go towards negative infinity. All right, a local maximum. I kind of talked about this. I have a local maximum here at 2, right? So maybe I'll say, what point is this? -1, 2, 3, 4. At -4, comma 2, I have a local maximum. And right at this point, right? 1, comma 0. Those are both called local maximums. Maxima is the plural. All right, what is the local minimum? I have 1 down here, right? This is what, -1, -2. And someone give me this other coordinate. What would I call this? 3, -1. So some of you need to practice x, comma, y. All right, our new words, I guess, for this unit are domain and range. As I look from left to right, this graph keeps going a little bit more and a little bit more, and it keeps going this way as well. So my domain is actually all real numbers. I can plug in, oh, thank you. All real numbers. Does anyone know what the fancy symbol for that is? It's a bold face capital R. So you use 2 straight lines and then you draw an R symbol. That means that your x value can be anything you want. Likewise, guess what? This arrow is pointing up forever and this arrow is pointing down forever. So your y values can also be all real numbers, anything you want. And we're going to practice domain and range a lot this unit, so you're more comfortable with that. All right, is the graph increasing or decreasing from -4 to -1? And that's referring to the x-axis. So where's -4? Right here. And where's -1? So in this section right here, what's happening to the graph? It's going down, right? So it is decreasing. You read it from left to right, and that section of the graph is going down. And what's the y-intercept of this function? So 0, -1 is my y-intercept. That's a lot of vocabulary. So math is kind of like another language, right? Look at all of these definitions and vocabulary words. I just want us to be kind of educated mathematicians so that if I use the word maximum, what's the maximum height of your projectile? Oh, you know that that's this point right here. Or what's the x-intercept? So you know that's this point right over here where it hits the ground. So if we have some common language, we can answer questions together. So if you would turn, and you can use a partner, go past your resources and look at page 200. So go past all the resources that are at the front and look to page 200, graph vocabulary practice. Does everybody see where that is? I kind of set up the practice the same way. There's like 10 pages of resources and then the practice for class. I'd like you and a partner. Oh, I didn't read that. I'd like you and a partner to go through. Do you think we should do one together first? This says, is the graph increasing or decreasing from -2 to 0? So I'm looking at that stretch of the graph. What do you think? I'm looking right here. From -2 to 0. What's that part of the graph doing? Increasing or decreasing? As you move your pencil from left to right, it is pointing down. It is decreasing. So you can circle decreasing for part A. All right, what about from 2 to 3? Here's 2 to 3, right? Because I'm looking on the x-axis between 2 and 3. What's this part of the graph doing? Right here. So as I read it from left to right, it's increasing. So we need to be good at identifying where is the graph increasing or decreasing. All right, what are the x-intercepts on this graph? There's 2 of them. What is it? Yep, so I can write it as -1, 0, and +3, 0. I'm going to write them as coordinates. What's my y-intercept this time? -3. So that would mean x is 0 and y is -3. Part E. It says evaluate the function when x equals 1. The other way that I could ask this question, what is f of 1? So that's asking you, when x is 1, what is the y value? So I go to 1, what's the y value right here at this point? So my answer is -4. So you're looking for the y value when x is 1. What's the highest y value that you get to? Infinite again. See the arrows pointing up? So I can write positive infinity for f. What's the lowest y value that I get to? Do I go down forever? Nope, I only get to -4. I don't get down forever. So my lowest y value is at -4. All right, here's our stretch. What's the domain of this function? So domain actually can go forever, left and right, because the arrows keep pushing the graph out. So the domain is still real numbers, but the range is not. See how my y values never go below -4? So this whole section of the graph I never get. So I would write it, y has to be greater than or equal to -4. The whole graph goes above -4. Here's another word I haven't used yet today, axis of symmetry. Is there anywhere I can cut this graph in half? Yes. So this is called, wait, cut it in half, -4? So I think that we're talking about a different axis of symmetry. To me, if I cut this graph in half, I would slice it down the middle like that. So that's an axis of symmetry. That's a vertical line at 1. So I write it as x equals 1, because that's how I write a vertical line. So that purple line, this line, that equation is x equals 1. That's called an axis of symmetry. If I folded it in half, it would go perfectly on top of itself. So this is not an axis of symmetry, right? Because if I folded that in half, it would not line up on top of itself. Not all graphs have axis of symmetry. Does this graph have an axis of symmetry? I can't fold it this way. I can't fold it this way, right? Does this graph have an axis of symmetry? That's one that we're going to look at. That's absolute value. Does this graph have an axis of symmetry? Maybe a diagonal axis of symmetry, but we're not going to really talk about that. All right, your turn. You and a partner answer numbers 2 and 3. Here is this graph decreasing. Kind of a trick question. It's decreasing the whole time, right? So you could say that it's decreasing. You could say everywhere. You could say on the interval from negative infinity to positive infinity, meaning forever. You could say all real numbers, meaning everywhere. So right, it's decreasing everywhere. The coordinates of y-intercept. You should have said 0, comma, positive 2. It's right there. The coordinates of the x-intercept. Right here on the x-axis is 4, comma, 0. I'd also allow you to say maybe y equals 2, x equals 4, if you wrote it like that. Okay, this is a tricky one. F of 2. That means what is y when x is 2? That's referring to this point right here. 2, comma, 1. So the y value would be 1 on that purple dot. My max and min. Well, this arrow can keep going up forever, and this arrow can keep going down forever. So I can go to positive infinity, and I can go all the way down to negative infinity. For a linear function, your domain and range are always all real numbers because the arrow's going side to side and up and down forever. Oh, and then here's a question from Unit 1. What's the equation of this function? What'd you say? Y equals negative 1/2 x plus 2. Who said that? Oh, very good. So keeping those Unit 1 skills sharp, because some of you want to retake that test next week, we're still talking about linear functions with some slightly different vocabulary. Okay, how about an application problem? See if you can answer the questions about analyzing this tadpoles in a pond. Questions. We'll play a quick round of this. Okay, what is the y-intercept and what does it represent? Y-intercept is 200, and what does that represent? Starting amount of tadpoles, or you could say tadpoles in 1990, right? So it's a starting population of tadpoles in 1990 in the pond, right? So we're trying to look at the scale and analyze like real world data. What was the maximum number of tadpoles to live in the pond, and in what year did this occur? What did you estimate? 1,500 in 1992? 1,500 in 1992. You did okay analyzing that number? What is the local minimum value, and what does it represent in regards to the data? What did you say? What's the local minimum? Yeah, so maybe about 300 tadpoles in 1993. Why is that relevant? Something drastic happened in the pond in this year, right? So maybe there was a harsh winter, maybe a chemical spill, maybe there was an overpopulation of fish. They restocked the fish. Something happened right here that dipped this minimum, right? So we'll say 300 tadpoles in 1993, and we could just get a big dip in the population. So we're not sure why, but that would be a good thing to analyze if you were a scientist. What was going on here? Maybe you're studying DDT and the effects of pesticides on the neighboring pond or something like that. Is there increasing or decreasing beyond 1997? What does it look like? It looks like it's decreasing, but I can really only predict up through 1999. I don't have any data after 1999. This is pretty old data. Sorry about that. What's the rate of change between 1990 and 1992? Is that what it is? We are going from 200 up to 1500. So 1300 is the increase over a period of 2 years. Very good. Or you could say 650, about tadpoles per year. The slope is a rate of change. So they're increasing by 650 tadpoles every year. You think you could use some